All right, welcome back to the third of our fourth part of the sequences and series unit, and this is arithmetic series. I'm going to try a different experiment for this and the geometric series videos, and that is working directly on the guided notes that you see. I tend to feel like they're a bit much to have on a page, but I will be interested to see what you all think works better. So, starting with vocabulary, because math is its own language, and a lot of times one of the bigger obstacles to understanding is just knowing what all the words mean. So we're going to put them in one place right here. And a series is the sum of the terms of a sequence. And so, if we have the sequence, and we're used to seeing these, the sequence 3, 6, 9, 12, and 15, hopefully you recognize right away as an arithmetic sequence. It has a difference, or d is equal to plus 3. Well, if instead of just having this set of numbers, we actually wanted to know what is the sum of those numbers, that's, instead of saying the sum of the terms of a sequence, we say the series. And so in this particular case, the sum of this particular series, which has 1, 2, 3, 4, 5 terms, the sum is just adding them up. 3 plus 6 is 9, plus 9 is 18, plus 12 is 30, plus 15 is 45. If you happen to have an infinite number of terms, so let's take a different kind of sequence. Let's say it was actually 2, 5, 8, 11, 14, and so on. Well, the series 2 plus 5 plus 8 plus 11 plus 14 goes on forever. So it's called an infinite series. And it actually has an infinite number of terms that are summed up. And any series whose terms form an arithmetic sequence is known as, you guessed it, an arithmetic series. So 1, 5, 9, 13, 17, 21, if we add them all up, it's an arithmetic series with 1, 2, 3, 4, 5, 6 terms. So the relationship is the sequence is a list of numbers, the series is the sum of those numbers. A lot of times, well actually almost all the time in math, we use a notation that's called sigma or summation notation. And so summation notation is the sum of the terms of the sequence that we denote the sum from, sometimes we use k, sometimes we use n. I'm going to stick with n. N equals 1 to n of a sub n, where n is the summation. So in this particular example, I kind of bled over into this, I know. This tells us that we have, let me get a different color here, the sum that starts at n equals 1, and it ends at n equals 5, and for every single different n, we're going to add up all the terms. So 1 for n equals 1, n equals 2, n equals 3, n equals 4, and n equals 5. So we're going to we would figure out what those terms are, and then we would add them up. And so I am going to tell you that this equals 35. And see if you can get there yourself, although we will do this in class also. All right. So in summation notation, the least and greatest integer values of that index n, or where I said it starts and ends, those are called the limits. So, to a different color. This is your lower limit. And this one's called your upper limit. So in this example, the limits are 1 and 5. All right, so the last important thing are these two formulas, and this is most of what we're going to do in this part of the unit, and that is, how do you find capital S sub n is the notation for the sum of. And so this basically means the sum of all the terms up to n. And so S sub n is equal to n over 2 times the sum of the first term and the last term, if you happen to know the first and last terms. And this is only true, by the way, for arithmetic sequences. If you don't know the last term, then you can still find the nth sum term by taking n over 2 and multiplying it by 2 times the first term, a1, plus n minus 1 times d. So I'm sure you recognize this looks very similar to the formula for an arithmetic sequence, and that kind of makes sense because we're just adding up all the terms of an arithmetic sequence. Great.